This is lesson number 23 in Algebra 2, Graphical Solutions. And what we're going to do in this lesson is we're going to use some systems of equations, such as 3y minus 2x equals 6, and y plus x equals negative 1. So you've done these before using elimination and substitution. We're going to use a third system here, which is solving by graphing, and to be honest with you, I don't like this way. It's not as accurate. I'm not sure why they teach it, but they do, and we're just going to go through it pretty quickly just so you can kind of see how they do it, because I guess it's not a bad idea to at least learn how to graph these systems of equations. So what you have to do with these, first of all, is you have to change each one of these equations into the slope-intercept form. So we're going to change them both so that each one of them looks like that. So let's take the 3y minus 2y equals 6, 2x equals 6, and set it up into y equals mx plus b. So we add 2x, and we get 3y equals 2x plus 6, divide by 3, divide by 3, y equals, and then we split these up. 2, 3 plus 6 over 3. 6 over 3 is 2. So there is the first one in the slope-intercept form of the equation, 2/3 x plus 2. And now this second one will do y plus x equals negative 1. And y, we're going to move that x over, equals negative x minus 1 there. And this is our second equation. Okay, so now we have our two equations in slope-intercept form. Until they're in slope-intercept form, you can't graph them. Now that they're in slope-intercept form, we can graph them. So let's graph this one down here first. The y-intercept is 2, the slope is 2/3. So if the y-intercept is 2, that means it crosses y right there at 2. And then the slope is 2/3, and if you remember, slope is y over x, so that is 2/3. So from my y-intercept, I go y and then x to find my next point. So I go up 2, because that's y, over 3, which is my x, because they're positive. I went up 2, positive, over 3, positive. So that's my next point. Draw a line, and that's the line of this equation right here. Alright, so let's draw a line of this equation. My y-intercept is negative 1, it crosses y at negative 1, and my slope is it's negative x, so negative 1 is my slope, and to make that a fraction, I put it over 1, so that now I have a y over x. So I start at, again, my y-intercept is negative 1, and I go up or down 1 for y, and left or right 1 for x. So because that's negative, I have to go down 1, and then because this is positive, I go to the right 1. So I go from my y-intercept, down 1, negative, over 1, my positive, and I get a point right there. And I draw a line. And where those two lines cross is the solution to my system here, because my graph shows me 2 points. I had to get to this point right here where they cross, I had to go over and up. So I had to go over an x value, and however far I went to get here is my x value, and however high I went to get here was my y. So my x is negative, what does that look like? Maybe 1.5. And my y value is, gosh, maybe positive 1/2. See why I don't like this? It's just kind of a guess here where those two lines cross. I don't know where they cross exactly. So I just kind of get an estimate of an answer here, which sometimes an estimate of an answer is pretty much all you need. But the exact answer, if we were to use systems of equations, my exact answer would be my x is negative 9 over 5, and my y value is 4 over 5. Well, I couldn't have gotten that just looking at this crazy graph right over here. I mean, so I'm just kind of guessing, but at least I know. Okay, this is kind of where my answer is going to be, somewhere in here. And sometimes it's easier to put these two equations in slope-intercept form and graphing it and finding out approximately where the answer is than to actually do the systems of equations. So let's do one more and then we'll call it good. Okay, so there's my system of equations for example 23.2. And I'm going to put them in slope-intercept form. So we're going to take this top one and do that first. So we're going to add 2x to both sides. And it's in slope-intercept form. Y equals -3 is already in slope-intercept form. I can't do anything with that. So actually, if this were in slope-intercept form, mx plus b, notice I don't have an mx. So that means that my slope has to be 0. So it's really 0x minus 3 if I put it in slope-intercept form. So let's keep that in mind when we do this. So I've got my two problems right there and right there that I'm going to graph. So let's see if we can move this stuff over so we can get the graph in. So what I have circled are my answers. Let's get the graph up here and see if we can graph this. So let's graph this first one here. My y-intercept is, get myself a dot here, my y-intercept is +2. So there's +2. My slope is 2. My slope is 2, or 2 over 1. So that's kind of a big pin tip. So my 2 is my y, my 1 is my x. So that means from here I go up 2 over 1. And that gives me my other point. Draw my line here. And then let's do my other one in blue. And it's this one right here. My y-intercept is -3, so I'm down -3 on my y-axis. And this says I go up 0 over 0. So if I go up 0 over 0, I don't go anywhere. So that means my line is a horizontal line. Ooh, that's like perfect. Is a horizontal line, and this is where my answer is. So what does that look like? X is around, now how far am I from here? 1, 2, I'm just going to say 2.5. -2 1/2 maybe. And my y value is from here, 1, 2, well obviously it's going to be 3 because it's on that, so it's going to be -3 there. So my y is around -2.5, and my y is for sure -3. So if I were to change that to an improper fraction, it'd actually be -5/2, which I prefer. So my point where they intersect is going to be -5/2, -3. And if you did system of equations, fortunately for this one my graph is a little better. It's exactly what the answer is. So I'm good to go there. So anyway, that is how to graph systems of equations. Remember, where they intersect is your solution set. It's your answer. And that's it.